Oh, I'll start over. So my name is Daniel Riek. I manage the AI Center of Excellence in the Office of the CTO at Red Hat. And I'll co-present with Steven Huels. Steven, why don't you introduce yourself?
Yep. Hey there, everyone. So Steven Huels, I had been on the AICoE here for the last 4 years. Under Daniel, responsible for kind of where we were headed with our AI projects like Open Data Hub, AI Ops, AI DevSecOps, as well as the Intern Bootcamp program. In the last year, Red Hat made a move to productize parts of the Open Data Hub as a managed service on our managed OpenShift platform. And so as a result of that, the engineering functions under Sherrod Griffin went into engineering, and myself and a couple of the data scientists and other folks are now responsible for the business unit aspects, which, if that's an unfamiliar term, essentially means the kind of the sales vision, like overall direction, product direction, tracking customer aspects of the product.
Awesome. So I want to give get a little bit philosophical, right, to tell the background, which kind of also gives you a little bit more background on like what Bill talked about earlier with operate first. So overall, we see the hybrid cloud as a predominant operational paradigm for modern IT. So everyone knows cloud. The definition of hybrid cloud we use is that it's hybrid, as in it's not just a centralized public cloud where one big provider offers you everything. It's actually distributed operation, right? That includes moving down to the edge, because software needs to run close to the interaction, close to the data. People running their own private data centers, people using multiple clouds. So hybrid means it's not just one big centralized service provider. It's a distributed approach that uses different footprints down to the edge or your private data center, as well as could be using different cloud providers at the same time, and applications that consists out of centralized parts and front ends. For example, anything that consumers interact with has a front end on a mobile phone, right, which makes it a hybrid application by definition. And we use hybrid cloud to describe this complete context of running your things in a cloud native way, which means that you have the ability, what we call developer velocity, right? Developers can implement their goals without ever stopping. You have encapsulated operational excellence, which means that the system knows, or the providers operate things for you, so you don't have to figure out, you don't have to be an expert in every piece of component componentry that you need to use. And you have elasticity, which means you can scale up and down easily depending on your usage pattern. So that's what we call the hybrid cloud paradigm, and that's how people want to run their IT nowadays. Also, macro trend is that every business is implementing its business value in software today, right? The catchphrase is software aids the world. What we mean by that is that you can go into virtually any business today, and they will depend on software in their core business at some point. And it could be just their supply chain or their customer interactions, their marketing, these kind of things, their back office operations. But increasingly, it is actually the products themselves, the value of the products differentiates on the software level, right? There are a bunch of, an example you can use is that, like, if you have modern light switches have microcontrollers, right? And you can connect them to your home automation system, right? So a light switch now has software running inside. Or, I do have a mouse trap, which, sometimes you have to take care of a infestation of your pantry by rodents, and now I have a connected mouse trap, right, that informs me on what's going on, right? So something very basic now, and these are kind of fluent examples, but the point is that like software is really creating the differentiation even in the very mundane tasks and things that are very, very mechanical. in a sense. So that means that, you know, for companies that depend on this, right, increasingly, it becomes important that they're able to put their business value in software without ever being slowed down or held up. They don't want to be blocked by problems. And this is one of the key drivers for the expansion of the cloud paradigm, because cloud enables you to focus on the things where you care, where you differentiate in your business, and just consume everything else, right, without having to own all the complexity. And because we run the world with software, right, this is where this leads, that everything is run by software. That also means that the software stacks, you know, both like on the code level as well as the aggregation of services into complex deployments, actually starts to resemble the complexity of the physical world. Right? So, and you know, that creates ever-growing complexity in software. And also, you know, because the value of AI-backed automation, right, applications, these applications in which every business is implementing their business value, increasingly become intelligent applications that are applications that learn from data to improve over time, improve their behavior, right? And so the catchphrase here becomes AI is now eating software, and that means that, like, for these users, right, every company at the end will be using AI in their own software to some degree. And I use AI very loosely in the broader sense of the buzzword here, right? It could be simple statistics, but they're going to aggregate data. They're going to use that data to improve the value they provide the customer, and the data and the models, whether they're simple or, you know, machine learning models, will become part of how they implement business value. And then lastly, Moore's law is basically over. You know, so Moore's law was this idea that you could, in a certain time, like, increase the density of compute devices to keep up. Another term is Dennard scaling, and we just can't make CPUs any faster at this point anymore. At least not with reasonable cost and you know, heat generation and things like that. And so as a result, we're seeing a proliferation of domain-specific hardware, which becomes really important. So, you know, AI is driving that as well, which in turn increases the complexity, right? So that's some macro trends. And to extract, like, the key points here, right? AI and data centricity are really important, increasingly important, right? Everyone is a software company. Everyone wants to rely on cloud models to offload the complexity of the underlying dependencies that are required for them, but not differentiated. They don't help them differentiate. They just need them. And it's growing ever more complex. From a Red Hat point of view, you know, the direction I see this going, and this is where I put in the Office of the CTO disclaimer. Like, I'm looking at, this is not a product announcement. This is where I see strategically us going. Right? Historically, our value, and Bill spoke to that a little bit, was to democratize the access to enterprise open source software. That meant we use, you know, open source is the general equalizer in access to software as a capability, right? You're not blocked from getting the capability to run code anymore. And we provided subscriptions to enterprises to enable them to benefit from this open source model. Now, because of cloud, we have this trend to operationalization. That's a differentiator. Now, you know, the problem isn't anymore getting the software. Open source solved that problem, but now the problem is to actually run the software. You know, our business at the end is already an aggregation of knowledge, because we do not own the software we give to people. You know, you buy from Red Hat because Red Hat has the ability to secure your use of open source, make open source usable for you by aggregating knowledge, being able to influence open source, being able to fix things, and being able to have a trust relationship with a lot of customers. A lot of that is just because we have a lot of customers and we are doing this fixing, right? We are actually doing the maintenance of open source, and that enable us to do the maintenance of open source, right? Because we have the knowledge and the trust relationships with many customers from which we aggregate future knowledge. So one way to put it, like, flippant way to say, customers buy an insurance from us because we secure their way of using open source in their own software and to operate their dependencies. But also, I'd say they buy from us because we can generate new knowledge about open source when they need it. Right? And the interesting thing here is that, like, this is moving, right? The need of customers has moved from just needing the software because of these macro trends I described, to needing the ability to, or requiring the capability to build and maintain their own software, because now they are a software company, they're implementing business value in software, and they require the capability to then operate that software they create. Okay? So for us, that means we're moving beyond enterprise software into the operational side and the help customers write their own software. And because of the scale and complexity, we require AI-backed automation to achieve that. So that is kind of the framing of, like, what we're looking at, what we're trying to do. And analytics and AI, because of this shift, we see that as a fundamental shift in technology, industry, and society. And we think that repeatable human tasks will be replaced by automation, and specifically in IT, right? Churn tasks will be replaced by AI-backed automation, by machines that learning. Look at it like, if you look at self-driving cars, which is kind of a little bit elusive, but it's going to happen, right? The only debate is how fast. You can look at that like similarly, like we will get to self-driving computers. Right? There is no way around that. It doesn't mean that humans get replaced, right? There's always a point where like the human is in the loop. However, it means that we will get to a whole different scale on how many systems, how large a fleet you can manage, and how many services you can manage and effectively. And to some degree, it doesn't actually affect the number, because of the growing complexity that I referred to earlier. It doesn't necessarily affect the number of people you need. It just affects, like, it just allows the humans to keep up with the complexity of the software stacks. And from a writer point of view, we can apply this technology in different ways. So we created the AI Center of Excellence to help with that. Red Hat's AI strategy framework has basically 5 components. The first one was AI is a workload, we are a platform company, and so this is pretty obvious, right? Based on what I described, we have customers who want to use AI, so we need to provide them a platform to run their AI, the data science on top. Second, we can also apply AI to make open source development and production more scalable and more efficient. We can apply AI to our own platform to make it operationally more scalable and turn it into an intelligent platform. And then we can, because our customers, as described, need to implement like everything we do in the previous step, where we use AI to make our own development and operations and our platform better. Our customers have to do the same for their customers in turn, in their own in software implemented business value. And so we need to enable them to do that. And underneath is this foundation of data as the foundation, where which is more a cultural or say digital transformation topic, and of how do we turn organizations, our own organization and our customers and our communities into a data-centric model where they appreciate data and create an environment where you can effectively build intelligent applications. So our endeavors, this was all the philosophy. What do we actually do? Right, the first project was Open Data Hub, which graduated to product recently. We are still involved, and I'd let Steven maybe talk a little bit about what that turned into and where it's going.
Oh, you mean right now? Okay.
Yes.
You can tell we practice these handoffs. Yeah. So Daniel's right. So Open Data Hub, originally created, gosh, I don't know, 2016, 2017, basically in response to our internal need to be able to aggregate data and analyze it, that ultimately gain interest from customers when they had similar problems, and we would present our approach. And then we codified that into an open source project called Open Data Hub that became one of the foundations for how we communicated to customers about how they could deploy their AI/ML workloads on top of OpenShift. The idea at the time wasn't necessarily that we were going to create a product, but it was to build mindshare and a mindset with those customers that they could put those workloads on our platform with confidence and take advantage of our partner ecosystem, both on the software side for things like Auto AI, Auto ML, operationalizing AI, as well as on the hardware side with like accelerators like NVIDIA and Intel chips and whatnot to make so that they could optimize their platforms for their specific use cases. And that kind of became a central hub around which we had a lot of conversations around other Red Hat products and other capabilities to customers, so how they could deploy these things at the edge and how we could address these sort of emerging trends in business. And so as a result, probably in the last year now, we looked at a core set of the capabilities within Open Data Hub, right? So Open Data Hub itself has 35 or so open source projects that make it up. We're targeting about 5 of those for the initial managed service that really focuses on model experimentation, right? So the Jupyter Hub environment, the Jupyter Lab notebooks, TensorFlow, PyTorch, the ability to take a model, wrap it as a container, serve it, and then be able to recreate that pipeline over and over again. And we took those components and rolled them into a managed service, rolled that out. It's called Red Hat OpenShift Data Science. And then we also went to market with a handful of partners initially that are integrated into that environment. Again, continuing the vision that Red Hat is there as the connective tissue to be able to put together a more comprehensive solution, but that you can build on top of us with confidence. And continue to move workloads for AI/ML on top of OpenShift. Like, our mission still remains the same, right? It didn't change all of a sudden when we made the product to say like, hey, now Open Data Hub is going to go compete head to head with Watson Studio or head to head with SAS or head to head with Cloudera. We still want to embrace our partners and be able to provide a platform for customers to build around. And so in the middle of those two things, when you think of Open Data Hub as the upstream component and OpenShift Data Science as the thing the customer consumes, is this thing in the middle called Operate First. And that is essentially where we take parts of Open Data Hub that we think customers are going to be interested in. We put those into Operate First. And like Daniel said, we operate them at scale. We learn what we're not doing right. We fix it. We learn how to monitor it. We learn how to make it auto heal, all that kind of good stuff. And then out of Operate First, the mature components and the ones that we think are ready for customer consumption will get moved into the OpenShift Data Science platform. And so in this way, when you think about a managed service, at the end of the day, customers are buying managed services because they want that thing up and running. They don't want to be bothered with the operations behind it. Maybe they can't be bothered with them. And so we need to have confidence that our managed service, that we can operate it, keep it up and running, and all those kinds of great things. And so Operate First gives us that transition from pure open source upstream, lots of churn, lots of additions, lots of creativity, and the need for productization of a managed service to have stability, reliability, and scalability. And so that's where we incubated and derive that knowledge.
Thank you. And that is, I think that's an important point, that Open Data is the first full example of the Operate First paradigm applied in Red Hat, and continues to be the primary target for our work in that space. So that's really interesting, right? So we actually do, if you look at Operate First, trying to achieve 3 things, right? First of all, build operational excellence, so we know what it means to run our products, so we can make them operatable. Second, put engineering in the loop on that, so that they implement the operational excellence in the product itself, so it can stand up to the proprietary cloud vendors who right now are centralizing a lot of operational excellence, and we need to distribute that and democratize the operational excellence by putting it into the product itself. And lastly, push that concept into open source, because that's how we stand up, how we actually democratize something against a proprietary status quo. With the Open Data Hub, we actually do have a community-facing instance of a service running, in which we can learn within an open source community what it means to do this. And it provides an open source platform to open source communities, which is going to be really important, because if we all believe that every application is going to become an intelligent application to some degree, right? Right now, if you want to do that in open source, you either have to run an extremely complex stack yourself, which means you can't focus on your core business, your differentiated value as this specific open source project, because you have to spend a lot of energy on underlying dependencies. Or you have to use a proprietary provider, right, that runs this for you. And that's really a bad model that undermines open source at its core. With Operate First and Open Data Hub, we actually have the ability to provide an open source answer to that, right? We do have a community instance running, and everything in there is open source itself, including the operations, which means that if you decide to run your own version, right, we actually want people to replicate that. And if they do that, then we collaborate in open source on the operational side as much as the code itself. So we think that's a very important project that will actually has a potential to change a lot of things around operations, right? And the other endeavors we are engaged in are built around that to more, some degree, right? AIOps and Operate First itself, right? That is team, and I think later on Marcel will talk a little bit about that. So that is part of the Operate First initiative. As the AICoE, we run this Open Data Hub instance there, and with the specific goal to not only provide Open Data Hub to community, but then specifically use data science to extract knowledge and create and implement the operational excellence together with the product team, right? So ultimately, like, if you go deeper into the OpenShift model, like this would be, so there's a concept called an operator, which is a piece of software like that is kind of a sidecar to your application that encapsulates certain operational tasks like installation, deployment, updates, operational tasks, day two operations. And the goal is to get to what we call level 5 operators, which would be autopilot operators that use AI augmentation to improve the scale and operational quality of the software. So that's what we do in this AIOps Operate First context, using Open Data Hub as the proof point. AI DevSecOps is another related team that is working on the question of how do I create and maintain my software. An example, this is around handing off the software, the ongoing software lifecycle management to automation, and using, for example, AI-backed bots and guidance systems to offload churn tasks in your software maintenance. An example, so one of the targets where we are trying to prove this out is data scientists on top of Open Data Hub/Roads. So there's, for example, a Jupyter Lab plugin that manages your dependencies, right? As a data scientist, you want to focus on maybe TensorFlow and Pandas, right? But then TensorFlow and Pandas have a whole bunch of dependencies on their own, transitive dependencies that get pulled in, and you really don't want to deal with them. You don't want to have to wonder whether they break. You don't want to be bothered by security issues in them. So there are bots and automation tools that will do that for you, and automatically maintain your software stack. Right? That's an example of what we're trying in AI DevSecOps, and this includes patterns for curated stacks that you can use. It includes patterns for the pipelines that you use to maintain your own code, right? Because like the problem doesn't stop with like, oh, I get TensorFlow. You're going to use TensorFlow in your own model, and there's a pattern for automated tecton pipeline that then, with the help of some bot, will automate that process, maintaining your own application for you. We also do some AI research, specifically around the application of AI in the core tool chain, like compiler optimization, things like that. But also some broader cooperation with our research group under Hugh Brock, and Sarah, you probably talk to, and we do some general data science enablement across the product groups in Red Hat, where we collaborate with people and provide expertise to them. So that is the AICoE, and with that I hand over for questions. Is there any? Oh.
No questions at all. We did really good this year. It was perfectly
That's
clear.
one way, or we lost everyone.
That's right.
And they're like, oh, who are these people? What they're talking about? To quote my daughter, whatever.
Thank you, Daniel. Thank you, Steven. But yes, just waiting for a few more minutes to see if you guys have any questions before we move on to other sessions. And just to reiterate, that Steven and Daniel also mentioned that we have these other subgroups. So we will be having sessions tomorrow by Marcel and Christoph, who will talk a little bit more about what AI Ops is, what is AI DevSecOps. So, and today also we actually have a session for what is Open Data Hub and roads. So yeah, this is hopefully gives you a better high-level overview of what these sessions should look like.
Yeah, and the homework for tomorrow for the AI Ops and AI DevSecOps sessions is prepare questions. Don't stop laughing. Everybody I can see is laughing. It's meant serious, right?
Yeah, no. I'm laughing in full support. I think that's a great idea. Yeah. And you can ask Christoph and Marcel and I don't know who's presenting Data Hub and roads.
So we do have Landon presenting up next. Yeah.
Awesome. Yeah. So ask them questions, right? Like even if you have some questions after this presentation, they all, it's also they actually can answer them. Well, Steven and I are just the managers. And
I'll be texting them in the background. Hey, what's the question?
All right.
All right, if there's no questions, I'll drop. But welcome to Red Hat. I hope you have a great kickoff here. And if you do think of questions later, we're easy to get a hold of.
Yeah.
The show.
All right. Thank you very much. Welcome.
Thank you.